Hello and welcome back to Alex SpaceX Talks. Today with another SpaceX-ABC-series episode, letter I for interplanetary travel. When it comes to space travel, human beings have last set foot on the moon almost 55 years ago. Since then, nothing really happened in manned space exploration. Elon Musk and his company SpaceX want to reach Mars with the mighty Starship rocket, currently being built at Starbase, Texas, which is still in an early prototype state. But the issue with reaching Mars and thus traveling between the planets in our solar system is not only that we currently don't have a rocket available. There are much more hurdles to overcome in traveling to Mars and other planets. I would like to highlight 11 of them, which were all in detail discussed in an article published in 2016 in the Wired magazine. Number 1. Taking off from Earth. The Earth's gravity field is very strong, and hence a spacecraft leaving Earth must be propelled to a velocity of 11.2 kilometers per second. This requires an enormous amount of energy and therefore fuel. That is why our starships traveling to Mars first need to be fully refueled on their journey to the Red Planet once they have reached low Earth orbit. Number 2. Propulsion. Our ships are way too slow. The larger an object's mass, the more force it takes to move it, and rockets are kind of massive. Chemical propellants are great for an initial push, but your precious kerosene will burn up in a matter of minutes. After that, expect to reach the moons of Jupiter in 5 to 7 years. Therefore, propulsion needs a radical new method soon. Number 3. Space junk. It's a minefield up there. This is the problem of space debris, and it's very real. The US Space Surveillance Network has eyes on 17,000 objects, each at least the size of a softball, hurtling around Earth at the speed of more than 17,500 miles per hour. If you count pieces under 10 centimeters, it's closer to 500,000 objects. Number 4. Navigation. There's no GPS for space yet. The Deep Space Network, a collection of antenna arrays in California, Australia and Spain, is the only navigation tool for space. An ultra-precise atomic clock on Earth times how long it takes for a signal to get from the network to a spacecraft and back, and navigators use that to determine the craft's position. The farther rockets go from Earth, however, the less reliable this method becomes. For future missions, deep space navigation experts want to design an autonomous system that would collect images of targets and nearby objects and use their relative location to triangulate a spaceship's coordinates, no ground control required. Number 5. Radiation. Maybe the fiercest hazard of a human mission to Mars is also the most difficult to visualize because, well, space radiation is invisible to the human eye. Radiation is not only stealthy, but considered one of the most menacing of all the hazards. The space station, for example, sits just within Earth's protective magnetic field, so while our astronauts are exposed to 10 times higher radiation than on Earth, it's still a smaller dose than what deep space has in store. Number 6. Food and water. Mars currently has no supermarkets, so everything needs to be transported to the Red Planet as well. Our astronauts would need to rely on multiple Starship cargo missions to refill their fridge. Number 7. Bone and muscle wasting. The variance of gravity that astronauts will encounter is a severe hazard of a human mission. On Mars, astronauts would need to live and work in 3/8 of Earth's gravitational pull for up to 2 years. Additionally, on the 6-month trek between the planets, explorers will experience total weightlessness, which has an enormous negative effect on the human body. Number 8. Mental health. Interplanetary voyages are a direct flight to space madness. Behavioral issues among groups of people crammed in a small space over a long period of time, no matter how well trained they are inevitable. Crews will be carefully chosen, trained and supported to ensure they can work effectively as a team for months or years in space. Number 9. Touchdown. Crashing is not an option. Starship, for example, will enter Mars's atmosphere at 7.5 kilometers per second and decelerate aerodynamically. The vehicle's heat shield is designed to withstand multiple entries. Starship will be slowed down by the atmosphere and will land by reigniting its Raptor engines. So far the theory, but after 6 months of traveling through space, landing on Mars is for sure not an easy task. Number 10. Resources. When space caravans embark from Earth, they'll leave full of supplies. But you can't take everything with you. Seeds, oxygen generators, maybe a few machines for building infrastructure. But settlers will have to harvest or make everything else. Mars currently has not much to offer. Number 11. Distance from Earth. The most apparent hazard is, quite simply, the distance. Mars, for example, is on average 140 million miles from Earth. Rather than a 3-day lunar trip, astronauts would be leaving our planet for roughly 3 years. Facing a communication delay of up to 20 minutes one way and the possibility of equipment failures or a medical emergency, astronauts must be capable of confronting an array of situations without support from their fellow team on Earth. You see, interplanetary travel is not an easy task, and it is not simply done with building a rocket. Well, that was all for today, folks. I hope that you have all enjoyed this special episode. I wish you all a wonderful week, and I'm hoping to be seeing you soon in my next video. Ciao.
We got tactical smart missiles, phase plasma pulse rifles, RPGs, we got sonic electronic ball breakers. We got nukes, we got knives, sharp sticks.
Knock it off, Hudson.